Welcome to the MST Global Technology Series. I'm Nicolette Baker, your host for this series. Today we're interviewing Denis Kent, Product Manager at MST. Denis has been with the business since it started in 1989 and is going to share with us today the reasons why MST was started and how the same methodology for creating high quality products are still with us today. Thank you for joining us today, Denis.
Thank you, Nicolette. I look forward to talking about it. I have enjoyed the whole history of MST, so it's very good to be involved in capturing some of that history and the philosophy behind MST.
Perfect. So kicking off, you've got obviously a very long-standing career at MST. Can you tell us a little bit about how MST started?
Yeah, MST was started by a fellow called Gary Zemmel, who was a mining engineer who spent most of his career on the supply side of the mining industry and working for overseas companies. And what he realised, Australia was such a good mining nation that we should be able to develop our own technologies within Australian mining industry and have credibility to export them overseas. So that was his fundamental idea of going out and forming the company. And he was quite open to the technologies that it may lead, whether it was mechanical or electronic or whatever it may be. We wouldn't be building huge mining machines, but smart technologies was the basis of it. And what happened in 1986, just as he was forming the company, there was a mine disaster in Queensland where 12 miners were killed at Mara No. 4 mine. And that really shocked the industry. It was a severe incident, obviously, and tragic for the whole of the Queensland industry and the communities. So the government, through a scheme called the National Energy Research and Development and Demonstration Council, NERDC for short, made a special allowance of money available for research into mine safety. And a number of people in the industry encouraged Gary to put in a submission on some smart technology developed, because traditionally these NERDC grants had gone to universities and large research institutes and really produced reports that sat on bookshelves, and there was some valuable information, but nothing that the industry could put their hands on, you could say. So Gary talked amongst a range of people internationally, one being Miklos Shalaman, who was a renowned geomechanic engineer and mining engineer that headed the Chamber of Mines in South Africa for 23 years. And he threw out the comment that during an emergency or a disaster underground, all forms of communication are generally lost, especially when in coal mines with large explosions and fires. And maybe there's some way of being able to communicate to miners and give them directions of the best escape routes. That was the idea thrown at Gary, and he talked then with a number of CSIRO people, other miners in Australia, and came up with the concept for what ended up being the PED, the Personal Emergency Device Communication System. So that sort of gave Gary 2 years worth of funding, which was fortunate enough that he was able to employ me. At least I could see that I had 2 years of being able to feed myself, and it sounded a very interesting challenge, having my background, having been in working in underground coal mines in the Mullenweg region for 10 or 11 years. It seemed something different to try, so I came on board and project managed the PED from 1987 to 1989 when we developed the product. So it sort of set the pace that communications and electronics was probably the way that the company would go. So officially, as the product was finished, Mindsite Technologies was formed as the company name and went to market with that first system. And it was very...
Right, so that's... Sorry.
Go ahead.
I was just going to say that's such an interesting story about how it all kicked off and began. And I guess it just really talks mainly about that there was an industry problem, a situation that occurred, and that Gary and yourself were very focused on creating some type, a type of solution that could better, create safer and more productive mines. So I'm just wondering, was there any other products like that on the market, or how did people at that point in time communicate with underground miners?
Very crudely, in fact, in most of the coal mines in particular, all they had were fixed phones at various locations through the mines. Hard rock mines were starting to use what we call leaky feeder radio systems, so it gave a bit more broad coverage just on the main travel roads. But that was also, it was actually quite limited. It was either you had to be near a phone to hear it ring, or in a certain roadway to be able to call up or hear messages on the radio. And so there's a lot of mine that wasn't covered, and people are often in these areas for various reasons, going from job sites, doing expansions. So there was nothing around, and the concept of actually transmitting signals through the earth was what we could see as a way of overcoming the problem, so that you weren't reliant on being line of sight to some sort of antenna underground in the mine. And that also solved the problem. If you could put the antenna on a surface, whatever happened underground, the system would keep working, and any of people that was in the mine, you could get messages to them, albeit it was only a one-way system. So still, a phone system or radio system certainly complemented it in day-to-day use, but in an emergency, it was often would be the only thing. So what happened, it certainly met a need, and the first two installations of the PED system sort of drove home to both of us how that providing a solution to a problem or a requirement at a mine was vital. So the first installation of PED occurred in 1990 at a coal mine in the Wollongong region. And the reason that they chose it, they were reorganising their workforce to take electricians and fitters out of the working panels so they could do work elsewhere, because traditionally they'd often sat on their backsides for hours at a time waiting for something possibly to break down or something to happen. So they wanted to utilise those tradespeople in maintenance and various tasks out by in the mine, and then if there was a breakdown at the face, they wanted to be able to get hold of those people very quickly to be able to get them into the face and get back into production. And fixed phones and even a radio system didn't work where these people were working, but the PED was ideal. Wherever they are, we could send a message, grab your tools, please go to panel 102. So it solved their solution. They bought it, installed it. It was their first system. And the second one was more a safety-driven requirement, in that there was a tragedy in Western Australia in a gold mine where a flash flood occurred, and the filled up an old open pit which had a decline running off it for the rest of the mine where they'd gone underground, and it trapped 5 miners underground, and the mine manager actually jumped in a vehicle to try and drive down to warn them what was happening, because he could see what was about to happen, and he got drowned as well. So it was a small development crew, but 6 people were killed. So Western Mining Corporation, that owned the mine up near Leinster, they identified PED was a technology that would have certainly assisted or maybe even avoided this accident. And they, over the next 2 to 3 years, installed the PED system in all of their mines. So 8 or 9 operations eventually rolled out PED as an emergency warning system, and they still had their radio system and some phones, and that all worked together very well.
Wow, sounds like a really unique piece of technology that you were able to build that was obviously very useful. So that's great. How do you believe that MST has continued the same methodology of addressing customer industries, situation over time and creating a solution?
It's simply listening to the industry. We weren't trying to do everything, so we focused particularly on underground mining in general, but underground mining was not well addressed at all with technologies. And so we talked to people, we visited mines, we went to conferences, and we got a name for being able to hear about some issues, requirements, and develop some solutions. And from that, between a group of miners we talked to, you realise what would be required. And we saw that two-way communications to complement PED was obvious. So we started to develop a leaky feeder radio system that became available in 1995. And the mines are continuing to use it this day. What we also did was the PED signal, this unique signal that we had, and there's been 2 or 3 companies tried to replicate it, and no one succeeded commercially to have systems installed at mines. We had this great signal through the mine. We thought, what else can we do with it? And we took a concept to Mount Isa Mines and Olympic Dam at the time of whether we could use that signal to remotely operate equipment, and in particular to maybe set up a blasting device to avoid the use of a lot of hardwired cabling that used to go into the mines to allow safe firing from the surface. And they identified the potential savings immediately. And so we produced our blast bed system, which is a device that sits down. You have a short run of cable to a face, and by special commands transmitted through the earth, this unit arms and then it initiates the blast. And it saved the mines, they say, about usually on average about 45 minutes production per shift, just that they avoided doing all this other wiring up they traditionally have to do. So it was, again, they was listening to the industry. And more recently, of course, we've listened to the industry, and we could see the rest of the world was converging communications onto IP networks, and the internet was becoming available, and bandwidth was becoming key. And certainly PED couldn't meet that bandwidth. Leaky feeder, despite many attempts by people, couldn't meet that requirement. So we looked at digital systems and IP networks for underground, and that's where our efforts have been, particularly over the last 15 years, has been on the digital side, because mines needed bandwidth, more automation, more remote control required, and that all requires data.
Fantastic. So tell me, let's change gears and talk to me about customer situations and trends over time. Do you believe that customer situations have changed?
Yes, they go through, as everyone knows and we've heard about, is the boom and bust cycles in mining. And what they've matured enough now that they know that a boom will only last so long, and they need to prepare to work through a downturn in pricing and the cycle. So the mines over the last 10 years have been, or the last 6 or 7 really, after the last mining boom, they've come back and they've realised that their cost of the operation is critical. The productivity is the key that will get them through any downturn in the industry. As pricing of the commodities drops, if you're in the bottom quartile of cost of producers, you're going to survive and almost thrive during those periods. So they put a lot of effort into setting up the mines to be efficient. And like the rest of the industry and we're used to in the world, you look at the productivity gains that have been gained by using IP technologies and communications and mobile phones. They're integral to any sort of safe and productive environment. What we wanted to do is make that same connectivity available to the underground environment so that the mines could go through with remote mining, remote control, right through to fully autonomous mines, and also for safety to be able to communicate with people, to monitor the mine more accurately, get the data back, analyse the data, be able to communicate corrective actions underground. So it's all been rolled in with the mines now as the commodity prices are picked up. They haven't just gone berserk like they did in the past, just trying to get every ton out of the ground to while the prices are good. They've kept themselves in control so that they will remain efficient and they don't let fat get into the system that would hurt them badly during a downturn. So the connectivity and handling of personal communications and data in that time has probably been the biggest thing we've seen change. And then each end of that are the devices that operate off those systems underground, and the software and ERP systems that utilise, analyse the data, and then be able to push actions back down underground in an efficient way to make improvements. It's the short interval control is a common term now, which really means don't wait for the end of a shift or day before you actually find out there's a problem, find out about it within a few minutes, and then an hour later you're back on track because you've taken all the you've identified it and you've taken corrective action. So enabling those systems to work is where we see we've fitted in, we've provided that high level of connectivity and reliability on a purpose-built system for underground mines.
That's great. Absolutely, and you can see that through that things have changed dramatically over time. And I guess something that MST has been talking a lot about and has been creating a lot of products over the last 10 to 15 years is about creating that digital ecosystem and building that in that space, about smart network infrastructure and all the things to help build that ecosystem. So looking forward, how do you believe MST will continue to deliver on technology that enables safety and productivity?
It's, again, we'll be keeping our eyes on what the mining industry is wanting to do. and also the technologies that the rest of the world is using these days. So the two main efforts are to ensure that connectivity takes into account of modern technologies coming in, being 5G, LTE, is certainly a topical, and being able to use that underground is, unless someone's actually tried it, it's not simple at this stage. But it will be simple, and we're going to be a key part of making it relatively simple to use in the underground environment with our Axon platform. That was a dedicated underground network that I like to think of as the main features of it is the Axon core, which is like a communication hub in the mine that uses the standard Wi-Fi and IP protocols and fiber connection, but it also has connectivity to allow the use of Bluetooth gateways, LoRa, and LTE, so that they're much easier to not only install but maintain in a mine. And that's always been the challenge with some of these new technologies, is that the connectivity they needed has been cumbersome and expensive to do. If you tried to use a carpeted office off-the-shelf product, it's been a challenge. We've made that much easier, and we want to continue the role the same with the newer emerging communication technologies. And the other key aspect that we're concentrating on, of course, is the software and the business intelligence. We've always had open platforms, and we've fed into ERP and BI systems from third-party vendors and maintenance packages, and we will continue to do that. But the mines, seeing what we've done, have encouraged us to develop our reporting and analytic software more, so that we can provide a total package to them. And so a lot of effort is going in to be able to provide that total package. But as I said, we'll certainly remain open. There's certain software packages or maintenance systems that a mine prefers to use, then we're more than happy, being the data highway, to facilitate those systems to work well.
That's fantastic. Well, it's been great hearing from you today, Denis, and thank you very much for your insights and knowledge. Obviously, you've got a lot of experience across underground mining and in technology as well. So thank you very much for joining us today. I really appreciate it.
Thanks, Nicolette. It's always good to talk about the history. It's something the individuals in MST are very proud of, and I've been fortunate enough to be on the full journey. So it's been an excellent time, and I'm just as excited today as I was back in 1987. So that says something.
That's fantastic. Thanks, Denis.